Welcome to my channel Cherish Physics. Subscribe my channel and keep watching. When the temperature increases, the surface tension of a liquid dash. The answer is the surface tension of a liquid decreases. Surface energy is the dash. The answer is surface energy is the surface potential energy per unit area. The force of attraction between molecules of different substance is known as dash. The answer is adhesive force. Fourth question. Excess of pressure inside a spherical air bubble of radius r is dash. The answer is 2T divided by R. The dimension of surface tension is dash. The answer is mt to the power minus 2. The rise of oil in the wick of a lamp is due to dash. The answer is surface tension of the oil. Seventh question. Molecular forces are. The answer is short range attractive forces. Angle of contact of pure water with clean glass is. The answer is 0 degree. The shape of liquid meniscus in a capillary tube when the liquid does not wet the tube is dash. The answer is convex. 10th question. The rise of a liquid in a capillary tube is due to dash. The answer is surface tension. 11th question. Surface tension is due to dash. The answer is cohesive molecular forces. 12th question. If the radius of the tube increases 2 times, keeping other quantities constant, the rate of flow of liquid through a capillary tube is dash. The answer is the rate of flow of liquid through a capillary tube increases by 16 times. Let us see the solution. The given data is R is increased 2 times, that is R equal to 2R. According to Poisson's flow, the rate of flow of liquid through a capillary tube is proportional to R to the power 4. In the place of R, put 2R. So, V is proportional to 2R the whole power 4. Finally, the rate of flow of liquid is proportional to 16R to the power 4. 13th question. Which type of fluids have zero surface tension? The answer is ideal fluids. 14th question. Raindrops are spherical because of dash. The answer is surface tension. 15th question. Two plates of glass stick to each other when a few drops of water are put between them. This is because of dash. The answer is the excess of pressure inside the water film is negative. 16th question. The excess of pressure inside a liquid drop is PD and that inside a liquid bubble of same radius is PB. Which of the following relation is correct? The answer is option B, 2PD equal to PB. Let us see the solution. Watch the surface tension video in my YouTube channel. In that I have given the excess pressure formula for several cases. First, the excess pressure inside a liquid drop PD equal to 2T divided by R. Second one, the excess pressure inside a soap bubble PB equal to 4T divided by R. On comparing these two equations, we get 2 PD equal to PB. 17th question. The level of water rises while that of mercury is depressed in a glass capillary tube. This is because of dash. The answer is the angle of contact of water with glass is less than 90 degree and that of mercury is greater than 90 degree. 18th question. If the radius of the tube increases 2 times, keeping other quantities constant, the rate of flow of liquid through surface tension of a soap bubble is 2 into 10 to the power minus 2 Newton per meter. Work done to increase the radius of soap bubble from 3.5 cm to 7 cm will be dash. The answer is option C, 18.48 into 10 to the power minus 4 joule. Let us see the solution. First, the given data is T equal to 2 into 10 to the power minus 2 Newton per meter. Radius R1 equal to 3.5 centimeter, which is equal to 3.5 into 10 to the power minus 2 meter, and R2 equal to 7 centimeter, which is equal to 7 into 10 to the power minus 2 meter. We have to find the work done W equal to question mark. Work done to increase the radius of the soap bubble W equal to S into 8 pi into R2 squared minus R1 squared, which is equal to T into 8 pi R2 squared minus R1 squared, where S is the surface energy and T is the surface tension. As we already know, surface energy is numerically equal to surface tension. On substituting and simplifying step by step, we get the answer 18.48 into 10 to the power minus 4 joule. 19th question. The angle of contact between a glass capillary tube of length 10 cm and a liquid is 90 degree. If the capillary tube is dipped vertically in a liquid, then the liquid will dash. The answer is option D. The liquid will neither rise nor fall. 20th question. Calculate the pressure inside an air bubble below the water surface. Given data, surface tension of water equal to 72 into 10 to the power minus 3 Newton per meter. Atmospheric pressure equal to 1.012 into 10 to the power 5 Newton per meter squared. Radius of the bubble equal to 10 to the power minus 4 meter. The answer is option A, 1.0264 into 10 to the power 5 Newton per meter squared. Let us see the solution. We know the formula. Total pressure equal to atmospheric pressure plus excess of pressure, which is equal to atmospheric pressure plus 2T divided by R, where the excess of pressure of a air bubble is equal to 2T divided by R. Substitute the atmospheric pressure value 1.012 into 10 to the power 5 plus 2 into surface tension value 72 into 10 to the power minus 3 divided by radius 10 to the power minus 4. On simplifying the second term, we get 1440. The second term can be written as 0.0144 into 10 to the power 5. On adding these two values, we get 1.0264 into 10 to the power 5. 21st question. The surface of mercury in a glass capillary tube is convex and that of water is concave because option A and B are correct. The angle of contact of mercury with glass is greater than 90 degree and the angle of contact of water with glass is 0 degree. 22nd question. Liquid in small quantity will assume the form of spherical drop. This is because of dash. The answer is the sphere has the least surface area. 23rd question. A small drop of mercury is almost spherical, but a large drop on a glass plate is flat at the top. This is because of dash. The answer is option A and B are correct. That is, in a small spherical drop, surface tension effect is greater than that of gravitational effect, and in a large drop of mercury, the gravitational effect is larger than the surface tension effect. 24th question. Ball pen works on the principle of dash. The answer is surface tension. 25th question. An iron needle floats on the surface of water because of dash. The answer is surface tension. 26th question. Why can insects move on the surface of water without sinking? The answer is due to the surface tension of water. 27th question. Work done in blowing the soap bubble in the air of radius 2 r is W. Find the work done in blowing the soap bubble of radius r. The answer is W divided by 4. Let us see the solution. We know the formula. Work done in blowing a soap bubble W equal to T into 8 pi into R2 squared minus R1 squared. Here T is the surface tension, R2 is the final radius and R1 is the initial radius. According to the given question, let us take the initial radius R1 equal to 0. To the first condition, work done in blowing the soap bubble in the air of radius 2r is equal to T into 8 pi into 2r the whole squared minus 0, which is equal to 4 into T into 8 pi r squared. In the second case, soap bubble is blown to a radius r, so the work done is equal to T into 8 pi into r squared. On comparing equation 1 and 2, we get WR equal to W divided by 4. 28th question. Quincke's method is specifically well suited for measuring the surface tension of dash. The answer is mercury. 29th question. In Quincke's method, the surface tension of a large drop of mercury is calculated using the relation option A, T is equal to 1 by 2 into rho GH squared. 30th question. What does the parameter H represents in the standard formula for Quincke's method? The answer is option C, the vertical distance from the top of the drop to the point where the surface is vertical. 31st question. Quincke's method can also be used to determine which additional property? The answer is option B, angle of contact. 32nd question. Why is Quincke's method usually restricted to large drops? The answer is option B, because the formula assumes the drop is large enough for the surface at its maximum width to be considered vertical. 33rd question. Which instrument is typically used in the laboratory to measure the dimension in Quincke's method? The answer is option B, traveling microscope. 34th question. A spherical soap bubble of radius R1 and a cylindrical soap bubble of radius R2 are connected by a tube so that both have the same excess of pressure. Their radii will be such that dash. The answer is option C, R1 equal to 2R2. Let us see the solution. We know the formula. Excess pressure inside a soap bubble delta P equal to 4T divided by R. and the excess pressure inside the cylindrical bubble is delta P equal to 2T divided by R. On writing the formula with the given radius R1 and R2, we get excess pressure inside a soap bubble delta P equal to 4T divided by R1 and the excess pressure inside a cylindrical bubble delta P is equal to 2T divided by R2. In the given question, both the soap bubble have the same excess of pressure, that is delta P equal to same. So we can equate the right hand side. 4T divided by R1 equal to 2T divided by R2. Cancel the same terms and simplifying we get R1 equal to 2R2. 35th question. The dimension of coefficient of viscosity of liquid is dash. The answer is option D, m L to the power minus 1 T to the power minus 1. 36th question. As temperature is increased, the viscosity of liquid dash. The answer is option B, decreases. 37th question. Which of the following graph represents the variation of surface tension of water with temperature over a small temperature range? The answer is option C. Thank you.